Hi class, I want to present a little scenario for you. Here's what's happening. You're watching this video right now on like a recliner or at the kitchen table or something like that. And after you're done with the video, you close your computer or you leave that desktop wherever you're at, and your parents say, "So little Billy or Johnny or Susie, what did you learn today in math?" And you could say, I just learned how to simplify radicals by multiplying by the complex conjugate. No big deal. It's what I do. And they're going to think, wow, my child is a genius. And then you could totally fool them because really it's not all that difficult. But it sounds really cool, does it not? Let's just hear it one more time as I say it. What we're going to be doing today, 5.6 notes. We're going to simplify radicals just like we have been doing, but we're going to do it by multiplying by the complex conjugate. So it sounds very difficult, but it really isn't. What we do here, we have to rationalize the denominator. Is that what it said on this page? You could even say you could have even had it sound more impressive. You could say we're going to simplify radicals by rationalizing the denominator using multiplying by the complex conjugate. Wow! That sounds really good, doesn't it? We're going to simplify radicals by multiplying by the complex conjugate, and in that way rationalizing the denominator. This is good stuff. So we have to rationalize the denominator. What we have right now is we have irrational numbers in the denominator. Square root of 3, irrational. Square root of 7, irrational. What you learned in the first half of this lesson on a different video was that if we had 5 divided by square root 3, we multiplied both top and bottom by square root 3. However, what happens if you do that in this case? Because there's a binomial in the denominator, two different terms, if you were to multiply the whole denominator by the square root of 3, you would have to distribute here. So you would get a negative square root of 3 times the square root of 3, which is a negative 3. It'd be the negative square root of 9, which is 3. But now here, you would get a negative square root 21. So now, class, you still have a radical sign in the denominator. So you didn't rationalize anything. It's still irrational. So multiplying by the square root of 3 will not work. In the same way, multiplying by the square root of 7 will not work. So we have to do something else. Back in intermediate algebra A, what you learned is that if we have x squared minus 49, okay, that factored into x minus 7 times x plus 7. If you have x squared minus 4, that factored into x minus 2 times x plus 2. Right? This is called the difference of two squares. We also did that earlier in chapter 5. So class, if we were to FOIL these now, we would get the first term, x times x. The outside term, x times 7 is 7x. The inside term, a negative 7 times x is a negative 7x. And the last term, which is a negative 49. Notice how the positive 7x and the negative 7x cancel out, so we just get x squared minus 49. X squared minus 49. In the same way, we can multiply these. The middle two terms would cancel out, and we would get x squared minus 4 when we FOIL x squared minus 4. So when we FOIL those two, what happens is that the middle term cancels out. And what is the difference between this binomial and this binomial? The only difference is that this is a negative sign and this is a positive sign. The only difference between these two binomials is this is a negative sign and this is a positive sign. So class, what these blue circles that I have up here, these are called conjugates. Conjugates is a binomial pair that are almost identical except for one difference. The sign in between the first term and the second term is different. One of them is negative, one of them is positive. And what's so great about conjugates is once you multiply them together, the middle two terms cancel out. And when we are simplifying rationals by multiplying by the complex conjugate, that's what we're doing. We're eliminating the middle two terms. So we're going to get on to number 7 now. I'm trying to erase all this ink here. There we are. So I'm going to multiply the whole denominator by its conjugate. So its conjugate is the exact same thing. It's a negative square root 3 and the square root of 7. It's the same thing except the sign in between. This sign right here, you do the opposite of that. So if it's negative, you put a positive sign. If it's a positive sign right here, you put the negative right here. So because this one is negative, we're going to have the positive sign in the next one. So whenever you have two terms in the denominator, and one of them or both of them is a square root sign, then you have to multiply by the complex conjugate, and the conjugate is just the same binomial with just one difference. The sign has switched. So now, class, what you do to the bottom, you also have to do to the top. So the top also has to be multiplied by the negative square root 3 plus the square root of 7. Make sure this one is the exact same as this one, because you're multiplying both the top and the bottom by the exact same thing. Now I want to be very clear on this. You only change the sign in between the two terms. You don't change this sign. This sign still remains negative. Okay? So when you multiply by the conjugate, only change that middle sign. All right. And now, class, we're going to distribute the top, and we are going to FOIL the bottom. And you can see, as I FOIL the bottom, how the middle terms cancel out, and in that way, the irrational numbers disappear. We'll do the top first. We're going to take this 5 and distribute it amongst both of these two terms. So 5 times a negative 1 square root 3 is a negative 5 square root 3. This 5 times the positive square root 7 is a positive 5 square root 7. So the numerator is easy enough. Now the denominator, I'm going to do this slow the first time so you can kind of see where everything comes from. But as you guys are doing your homework, you could actually do this pretty quickly. On the rest of the notes, I'm going to do this pretty quickly for you. So we have a negative times a negative is now a positive. We're foiling here, so we're doing the first times the first. And the square root of 3 times the square root of 3 is the square root of 9. So we have a positive square root 9 when we multiply the first times the first. The O in FOIL is the outside. So we have a negative square root 3 times a positive square root 7 to give us a negative square root 21. You multiply the numbers underneath the radicals together. 3 times 7 is 21. And then we have a negative times a positive, so we get a negative square root 21. The O in FOIL says we're going to do inside next. A negative times a negative is a positive, and the square root of 7 times the square root of 3 is the square root of 21. And then lastly, we have our last term in FOIL. So a negative square root 7 times a positive square root 7. A negative times a positive is a negative. And square root 7 times square root 7 is square root 49. Now you might be saying right now, Mr. Berge, we have a bunch of irrational numbers in the denominator. We have square root 9, square root 21, square root 21, square root 49. Here's the beauty of multiplying by the complex conjugate. In the numerator, we stay the same. It's still a negative 5 square root 3 plus 5 square root 7. In the denominator, this square root 9 is a rational number. The square root of 9 is 3. Here's where those middle two terms cancel out. Whenever you have x minus 3 times x plus 3, remember how the middle two terms cancel out. The O and the I of FOIL cancel out. Same thing here. A negative square root 21 plus square root 21, those just cancel out. It's like saying a negative 5 plus 5 is 0. You don't even have to write it. A negative square root 21 plus square root 21, that makes a 0. So the middle two terms eliminated. And then you have this negative square root 49, and the square root of 49 is 7. So you have a negative 7. Whew! Your denominator is now rational. There's no more radical signs in your denominator. It means it's not irrational. It is now rational. So your answer is a negative 5 square root 3 plus 5 square root 7 divided by 3 minus 7. That is a negative 4. And this is your answer. You have successfully rationalized the denominator by multiplying by the complex conjugate. Don't you feel good about yourself? That's good stuff. Now, just to give you one warning, Excel math might have this, which would be the exact same thing. They might have a positive 5 square root 3 minus 5 square root 7 divided by a positive 4. Sometimes they like to have the positive sign come first. So instead of having this negative sign come first, they would just multiply everything by the negative 1. So in that case, it would just change the sign on all three of these. So be prepared to see that as well. All right, we are now on to the next one, number 8. In class, number 8 is a beast. Okay, there's a lot of simplifying. The process remains the same, just like we did for number 7, but simplifying this is quite an animal to tame. So let's work on it together. We see a radical sign right here and a radical sign right here. And because we see the subtraction sign in between, it is a binomial. And the only way to rationalize binomials is to multiply by the complex conjugate. So you're going to multiply by a negative 11 square root 10 plus the square root of 2. You're going to multiply by the same binomial with just one difference. The sign in between the two terms is different. Instead of negative in the first one, it's now positive in the second one. What you do to the bottom, you must also do to the top. So multiply the top also by a negative 11 square root 10 plus square root 2. All right, let's distribute the numerator. So when we distribute that 4 times both of these two terms, 4 times the negative 11 is a negative 44 square root 10. And 4 times the square root of 2 is a positive 4 square root 2. All right, in the denominator. Now, class, I'm just fine if you don't FOIL the O and the I, the inside term and the outside terms, because we all know that they're going to cancel out. They're going to do that every single time. So I'm not going to worry about you writing that. All you have to do is multiply the first times the first and the last times the last. Because we know with complex conjugates, the middle two terms always cancel out. So let's multiply the first times the first. A negative 11 times a negative 11 is a positive 121. Square root 10 times square root 10 is square root of 100, and the square root of 100 is 10. So 121 times 10 is going to be when you multiply the first times the first. Outside and the inside, those two terms cancel out, so now you just have the last. We have a negative times a positive, which is a negative, and square root 2 times square root 2 is 2. All right, so now your denominator is rational, so now we just need to clean up things. We need to simplify. In the numerator, we still have a negative 44 square root 10 plus 4 square root 2. For this one right here, we have 121 times 10, which is just 1,210. Does that make sense? That's the same thing as 121 times 10. So now, class, when we subtract 2 from that, 1, 2, 1, 0, subtract 2 is 1,208. 1,208. Now, this would be our answer if we can't reduce. However, on this one, we can reduce. All of our coefficients, so we're not going to reduce any radicals. We can't touch the radicals, okay? But if all three of these terms have a greatest common factor, you take that out. You take out what's actually called the least common multiple. So what goes into this term, and to this term, and into this term? Hopefully you say 4 does. So we're going to divide each of those by 4. So a negative 44 divided by 4 is a negative 11 square root 10. A positive 4 divided by 4 is 1 square root 2, or just plus the square root of 2. And then you have 1,208, divide that by 4, and you get, let me get my calculator out here, 302. 302. And this is as simple as we can make it, class. Always look, is the denominator rational? 302, that is a rational number. Can you reduce the square root of 10? You cannot. Can you reduce the square root of 2? You cannot. Can you take out any other common factors? You cannot. Remember, they only come out of the coefficients. This, and this. And it has to come out of all three of them. So keep that in mind as well. All right, moving on to the next one, number 9, where we now have variables involved. But the process remains the same. We're going to multiply by the complex conjugate, which is going to be the square root of x minus 2 square root y. It's the exact same binomial with one difference, the sign being switched. So multiply by the square root of x minus 2 square root y. Let's distribute the numerator. 3 times both of these two terms. 3 times the square root of x is 3 square root x. 3 times a negative 2 square root y is a negative 6 square root y. There's our numerator. In the denominator, square root x times square root x is x. Square root x times a negative 2 square root y and 2 square root y times the square root of x, those, remember, are going to cancel out. The outside and the inside terms always cancel out. So now we just need to do the last times the last. 2 times a negative 2 is a negative 4. And square root y times square root y is y. So we have 3 squared x minus 6 squared y over x minus 4y. And at this point, class, if you can reduce, you have to reduce the coefficients of all 4 of these. Okay, you can't just do 1 or 2 of them. You can't make this be 6/4 to 3/2. That is against math rules. Okay, if you're going to do a portion of them, you have to do all 4 of them. And as you can see, because this is a coefficient of 1, you can't reduce anything further. You can't cancel y and y. That is also against math rules. You could only cancel square root y's with other square root y's, or you could only cancel y's with other y's. You can't do square root y's with the variable y. Okay, you have to stay in the same world as going along with the same terminology that I've been using. So this is your answer. You can't get any more simplified than this. Why don't you guys try number 10 on your own, pause the video, and then check your work with mine after you're done. Hopefully you multiplied by the complex conjugate, which is the square root of x plus the square root of 7. Square root x plus square root 7. Distributing the numerator, square root x times square root x is x. Square root x times square root 7 is square root 7x. In the denominator, first times the first, square root x times square root x is x. And the last, a negative square root 7 times a positive square root 7 is a negative 7. And once again, class, this is as simplified as we can make it. X plus the square root of 7x divided by x minus 7. You cannot cancel these two. Like I said, the only thing that you could cancel is the coefficients of all 4 of these. And because you can't take out a greatest common factor with all 4 of those, you cannot cancel the x's. And in the same way, you can't cancel these 7's. That's against math rules. So our answer is this. Number 11, multiplying by the complex conjugate, 4 square root x minus 3 square root y. Multiply the top by that as well, 4 square root x minus 3 square root y. Distributive property, 4 times 4 square root x is 16 square root x. 4 times a negative 3 square root y is a negative 12 square root y. In the denominator, 4 squared x times 4 squared x is 16x. Last times the last, because the middle two terms are going to cancel out. 3 times a negative 3 is a negative 9. Square root y times square root y is y. All right, now it's very, very tempting to try to do more simplifying. I've seen so many test questions of people going like this now. 16, 16, that reduces. You cannot do that because you can only take out a greatest common factor of all of them. Some want to say, hey, I could take out 3 out of both of these to make 4/3. You cannot do that. If you take a 3 out of this one and this one, you also have to take a 3 out of this one and this one. But 3 doesn't go into 16, so you can't do that either. So it's frustrating for some students who want to be able to simplify and clean things up that way. You cannot. And just like other examples, you can't take the square root of x and divide it by x and cancel those. That is also illegal mathematically. You cannot do that. So people want to just clean this problem up and make it look prettier. But this one just remains ugly. And this is our answer, as big and ugly as it may be. Last one, number 12. We're going to multiply by the complex conjugate, so the square root of x minus the square root of 2. Multiply the top by that as well. Square root x minus the square root of 2. As we distribute the numerator, square root x times square root x is x. Square root x times negative square root 2 is a negative square root 2x. In the denominator, square root x times square root x is x. The outside and the inside terms cancel out, and the square root of 2 times the negative square root of 2 is a negative 2. And once again, this is as far as we can go. So we are all done. I want to prepare you. A lot of these, surprisingly, that we had in our notes didn't simplify any further than just distributing the top and foiling the bottom. I think on our Excel math, if I remember right, you're going to have a lot more problems that are going to reduce. So make sure that you look at that after the problem is over, after you think that you're done, after the denominator has now been rationalized. Make sure you see if you can reduce any terms, because that'll be very likely, I'm guessing, in our Excel math objectives of 59, 60, 61, 62. I hope you have great success with these as you're doing them at home or doing them in class. Make sure you let me know if you have any questions before school, after school, or during class.